Hello students, good afternoon. You are welcome in the MHTCET lecture number 6 for a chapter of chemical thermodynamics. In the lecture number 5, we have seen concept of maximum work, expression for maximum work done during reversible isothermal process, and then multiple choice questions based on the expression of W max. The important point we have studied there in lecture number 5 is how to calculate the approximate answer. We have not used logarithmic tables at all. Without using logarithmic tables, how to perform the calculations approximately, that we have studied. And from those approximate answers, how to identify the correct option from given 4 options, that we have studied. That is the important part in lecture number 5. Now in lecture number 6, this one, we have to see the concept of internal energy, then first law of thermodynamics, formulation of first law of thermodynamics, and then multiple choice questions. So let us start with the concept of internal energy. Internal energy is the summation of all various forms of energy associated with the system. Any system is associated with various forms of energy, because system is consisting many particles. Millions of the particles are present in a system, and those particles have different forms of energy. They may be present in a motion, therefore they are having the kinetic energy. They may be moving from one point to another point. They may be moving around their centrally situated own axis. They may undergo vibrations. So they are possessing certain quantity of kinetic energy, and still they are stable. Particles are stable, means they are also having potential energy. So internal energy is the summation of 2 forms of energy known as potential energy and kinetic energy. The summation of potential energy and kinetic energy is known as internal energy. Furthermore, potential energy is the summation of 2 forms of energy, that is nothing but intermolecular energy, E intermole, and intramolecular energy, E intramole. Now let us see what is meant by intermolecular energy and what is the intramolecular energy. We know substance, matter, is composed of many molecules, and those molecules are linked together by weak van der Waals forces of attraction, weak physical forces of attraction, and that energy, due to which the neighboring molecules are in contact with each other, they are brought in contact with each other by weak physical force of attraction, is known as intermolecular energy. What is intramolecular energy? It is the energy associated with the molecule. Molecule is made up of atoms, and the atoms are bonded together in a molecule by either ionic bonding or a covalent bonding, by maybe transfer of electron or sharing of electron, and that is a strong bond. The bond between neighboring atoms in a molecule is very strong. Therefore, intramolecular energy has a greater magnitude as compared with the intermolecular energy, and the summation, addition of intermolecular energy and intramolecular energy is known as potential energy. In the similar manner, kinetic energy is also of three forms. It is the energy due to translation, E-trans, energy due to rotation, energy due to vibration. These are three different forms of kinetic energy. What is meant by translational energy? If we see the monoatomic gases, they are continuously present in a random motion in haphazard manner. Monoatomic gases are moving in a random manner, haphazard manner. Randomly they are moving, haphazard motion they are possessing, and they are moving from one point to another point. The energy associated with them in zigzag manner motion is known as translational energy. Rotational energy is the energy where the atoms are moving around the centrally situated fixed axis. Atoms in a molecule are moving around the centrally situated fixed axis, and they show the original performance again and again. That is known as rotational energy. What is vibrational energy? Atoms are present in a molecule. They show the vibrations like spring of pen, spring of ball pen. They show the vibrations, and the energy associated with the vibrations is nothing but vibrational energy. All these three forms of energy gives the kinetic energy. These two forms of energy gives the potential energy. So totally potential energy is two forms, kinetic energy is of three forms, and the summation of all these five forms of energy is nothing but the internal energy. Internal energy is the summation of all five different forms of energy associated with the system. This internal energy of system is nothing but a state function. It is a state function. We have studied while studying the work done, how internal energy increases or how it decreases. There we have seen that during the process of expansion, see, two processes we have studied. During expansion, we know that final volume of gas is greater than initial volume. Means during expansion, volume of gas increases, piston moves up, volume of gas increases. Therefore, with increase in volume, we have studied that rate of collision of gas molecule decreases. With decrease in the rate of collision of gas molecule, their energy also decreases, and energy is capacity to do work. Therefore, work done decreases, and hence work of expansion is considered as a negative work. Whenever system does work on the surrounding, it is negative work because internal energy of the system decreases. Internal energy get decreased during the expansion. Therefore, work done decreases, and it is known as a negative work. On the other hand, we have seen this process also, process of compression. In the compression process, we have studied V2 final volume is less than initial volume. Final volume is less, initial volume is more. Initial volume is more, that is compressed, and final volume is less. Therefore, V2 is less than V1. Since V2 is less than V1, gas molecules are compressed. Rate of collision of gas molecule increases. With increase in the rate of collision of gas molecule, internal energy also increases, and with increase in internal energy, work done increases. Therefore, work of compression is known as positive work. In that manner, internal energy due to expansion decreases, internal energy due to compression increases, and we know that plus delta U increase in internal energy, minus delta U decrease in internal energy, plus Q heat absorbed by the system, minus Q heat lost by the system, plus W work of compression, minus W work of expansion. Those are the sign conventions for change in internal energy, change in work done, change in heat already we have studied. Now let us see what is the first law of thermodynamics. Now see here, what is first law of thermodynamics. At the start of this chapter, we have studied that there are many forms of energy and all the various forms of energy are convertible into each other, and conservation of energy is observed, and therefore, law of conservation of energy we have studied there also. Law of conservation of energy is stated as energy can neither be created nor destroyed. Just one form of energy is convertible into another form of energy, and the total quantity of energy remain constant because it is conserved. Therefore, that is the law of conservation of energy. And first law of thermodynamics is nothing but the law of conservation of energy. Therefore, it is also stated as a law of conservation of energy. See the theoretical statement. First law of thermodynamics can be stated as energy can neither be created nor destroyed. Just one form of energy is converted into another form of energy, and the total quantity of energy remain constant because it is conserved. Secondly, energy of universe remain constant. Energy of universe remain constant, irrespective of the processes taking place in the universe. In the universe, we know many chemical processes are present, many physical processes are taking place, many naturally occurring processes are taking place, but universe as a whole, if it is considered, energy of universe always remain constant. And third, energy of an isolated system remain constant. What is isolated system that we have studied? We have seen three types of systems. Open system is the system in which there is free exchange of both energy as well as matter take place with the surrounding. In a closed system, only energy can be exchanged but matter remain constant. Matter is not exchanged. And in isolated system, there is neither exchange of energy nor exchange of matter take place with the surrounding. Since in isolated system there is neither exchange of energy nor exchange of matter take place, therefore energy of isolated system remain constant. And one more statement is there, fourth statement. We know system plus surrounding will be equal to universe, and energy of universe remain constant, means the summation of energy of system and surrounding remaining constant. Now the important part is nothing but formulation of first law of thermodynamics. Formulation of first law of thermodynamics is nothing but the mathematical statement of first law of thermodynamics. Let us consider any system which has its initial internal energy U1. Any system which has the initial internal energy U1 at start. Initial internal energy is U1. How it is increased, that we have studied. Whenever any system is heated, means absorption of heat take place plus Q. Absorption of heat plus Q. Whenever system is heated, its U1 increases because the system absorbs heat plus Q. Further, we have studied that internal energy of the system also increases whenever work of compression is done plus W. Whenever work of compression is done, that is the work done by surrounding to system, at that time internal energy of system also increases, and this summation will become the final internal energy. So internal energy in the final state of system is nothing but a summation of internal energy in the initial state of system, then heat absorbed by the system, and work of compression, that is work done by surrounding onto the system. Therefore, from this equation, U2 minus U1 will be equal to Q plus W, and U2 minus U1 is a change in internal energy, that is delta U will be equal to Q plus W. Important over here to note that Q, heat absorbed by the system, is a path function. No doubt. It is not a state function. Q is a path function. Similarly, we have studied work done is also a path function, because work done during irreversible process is minus P delta V. Work done in vacuum is 0. Work done in reversible process is W max. If the process is changed, work done also changes. Therefore, work is path function. Heat absorbed by the system is also a path function, but their summation is nothing but a state function, change in internal energy. It is a state function. So here plus delta U is nothing but increase in internal energy. Minus delta U means decrease in internal energy. Plus delta U increase in internal energy, minus delta U decrease in internal energy. Then plus Q, heat absorbed by the system, heat absorbed. Minus Q means heat lost by the system. Plus W, it is work of compression. Work of compression, that is work done by surrounding to system, and minus W is the work of expansion, that is the work done by system onto the surrounding. These are the sign conventions, important sign conventions. Plus delta U, increase in internal energy, minus delta U, decrease in internal energy, plus Q, heat absorbed by the system, minus Q, heat lost by the system, plus W, work of compression, that is work done by surrounding to system, and minus W, that is work of expansion, that is the work done by, expansion means system to the surrounding. So that is there about first law of thermodynamics and its mathematical format. Now, on the basis of internal energy, that is what we have explained, and first law of thermodynamics, we have to see certain multiple choice questions. Now let us see questions from our book. Regular book we are using is the Target publication. See classical thinking questions. Question number 26. Which of the following is correct equation for expansion? Correct equation for expansion. These are the four equations given. Delta U is equal to delta W minus delta Q. Here they have given delta W means work done is a what they are telling that these are nothing but the state functions. So it is totally wrong. It is always a path function. A and C are completely wrong. Since delta W, delta Q they have given, these are wrong, A and C. Now remaining is B and D. And for the first law of thermodynamics, we have studied delta U, change in internal energy. It is a state function, but it is the summation of two path functions, heat absorbed by the system and work done on the system, work of compression on the system. Delta U is equal to Q plus W. This is the equation for first law of thermodynamics. This is written as plus W. If it is the process of expansion, answer comes to be negative for work done. Therefore, correct option is B. For question number 26, the correct option is B. Now see question number 27. A system absorbs 920 joule of heat and does work. System absorbs heat. The change in internal energy for the process is 460 joule. The work done by the system is, see what they have given, system absorbs means Q plus 920 joule. Absorption means heat is absorbed, therefore Q is plus. Sign conventions we have studied. Change in internal energy for the process is 460. Change in internal energy delta U will be equal to, they have one positive value, plus 460 joule. The work done by the system means W we have to calculate. We know this is the equation according to first law of thermodynamics. So delta U will be equal to Q plus W. Delta U will be equal to Q plus Q 920. So it is equal to plus 920. Now the change in internal energy for the process is 460. This part is nothing but 460 and we have to calculate the work done W. So from this equation W is there as it is and it comes to 460 minus 920, therefore W will be equal to minus 460 joule. They have given the four options. First option is plus 250 joule, second minus 250 joule, third plus 460 joule, 460 but plus, and last is minus 460 joule. So we have the last option. Option B is correct because we are getting W is equal to minus 460 joule. Now see question number 28. What is question number 28? In a process, system does 238 joule of work on the surrounding. System does work on the surrounding means W. Is it the process of compression or expansion? System to surrounding means it is expansion. and that is equal to minus 238 joule. By absorbing 54 joule of heat, heat is absorbed, so Q is plus 54 joule, and the change in internal energy we have to calculate, delta U we have to calculate. See, sign conventions are important. Work done by system to surrounding is expansion, therefore it is taken as negative work. Here they have given positive 238, they have given positive, but we have to consider as a negative. Why? Because it is the work done by system on the surrounding. In a process, system does work up to 38 joule of work on the surrounding. System to surrounding, work of expansion, so negative. By absorbing heat of absorption is positive. We have to calculate delta U. So according to first law of thermodynamics, delta U is equal to Q plus W. So delta U is equal to Q 54 plus W. W we have minus 238. So delta U will be equal to minus 8 minus 4, it is 4. 13 minus 5, again it is 8. 1 is carried. 2 minus 1, 1. Minus 184 joule. Now see the options. 4 options they have given. The first option is plus 54 joule. Second, plus 222 joule. Third, minus 184 joule. And last is minus 192 joule. So we are getting minus 184 joule. Therefore, third option is correct. Option C is correct for that question. Now let us see next question number 29. Now see question number 29. First law of thermodynamics introduces the concept of, we have seen different statements of first law of thermodynamics. In all, 4 theoretical statements we have studied. It is nothing but the law of conservation of energy. So how that is stated? Energy can neither be created nor destroyed. Just one form of energy is converted into another form of energy, and the total quantity of energy remain constant. Then we have seen energy of universe remain constant irrespective of different processes taking place in the universe. Since universe is the summation of system and surrounding, therefore the summation of energy of system and surrounding remain constant. And last we have studied energy of an isolated system remain constant, because isolated system is the system which will neither exchange energy nor matter with the surrounding. Now let us see the options. First option, first law of thermodynamics introduces concept of temperature. Wrong. Second, pressure. That is also wrong. Third, change in direction of reaction. No, there is change in direction of reaction. That is studied in the equilibrium. And last is conservation of energy. So last option is correct over here. Option B, it introduces, first law of thermodynamics introduces the concept of conservation of energy. Now question number 30. The law of conservation of energy states that, what is the statement? It is energy can neither be created nor destroyed. Just see the options directly. Directly see the options. First option, internal energy of system is constant. No, that is not there. That is the first law of thermodynamics. Then heat content of system is constant. The energy is neither created nor destroyed. So option C is right, because law of conservation of energy is stated as energy can neither be created nor destroyed. And question number 30, again problem. Delta U for the system that does 1000 calorie of work on surrounding. Means here we have to calculate delta U that does 1000 calorie of work on surrounding, system to surrounding. means work done is work of expansion minus 1000. We have to take it as a minus 1000 calorie work of expansion. Then when 200 calorie of heat is absorbed, Q heat is absorbed means Q is plus 200 calorie. Heat absorbed means Q is plus. It is the work done by system to surrounding, therefore W is taken as negative, and we have to calculate delta U. According to first law of thermodynamics, simply delta U is equal to Q plus W. Delta U we have to calculate. Q is 200, W is minus 1000. Therefore, answer is minus 800 calorie. These are the simple questions, classical thinking questions. Now, let us see some critical questions, critical thinking questions. Now let us see some critical thinking questions. Critical thinking. Question number 33. In a reaction, delta U is less than 0. Then the heat is. See here we have to study whether heat is lost or absorbed or no change or abnormal. Whatever that may be, that we have to find out. So for a reaction, let us consider the reaction. A is reactant converted to the product B. We know initial state of the system has internal energy U1 and final state of the system will have internal energy U2. Delta U will be equal to U2 minus U1, and this delta U is less than 0. Suppose if U1 is equal to 10 and U2 is equal to 11. What is delta U? Positive or negative? It is positive because it is 11 minus 10 plus 1. Positive. If this is 10, this is also 10. What is delta U? Is it positive, negative or 0? Now it is 0. 10 minus 10 will be 0. And now this is 10 and this is 9. Now 9 minus 10. 9 minus 10, answer is negative. Here answer is negative means less than 0. Less than 0. At that time reactant has greater energy and product has less energy. Reactant has 10, product has 9. So where that 1 goes, 1 is lost. Evolution of 1 take place and energy is evolved, therefore that process is exothermic process. Now see the options. They have given 4 options. Option A, change is 0, means heat change is 0, that is wrong. Second, heat is absorbed, that is also wrong. Third, heat is evolved, now that is correct. In that process, heat is evolved whenever delta U is less than 0. Now next question, question number 34. A gas absorbs 250 joule of heat and expands from 1 liter to 10 liter at constant external pressure of 0.5 atmosphere. Value of Q, W and delta U will be 3 values we have to find out. Q is directly given there. Gas absorbs 250 joule of heat. So what is Q? Q is nothing but plus 250 joule. That is very simple. Q is directly given as plus 250 joule. See 4 options they have given. 4 options. In the first option, what is sequence? First answer Q, then W and then delta U. So in the first option, Q is positive plus 250. That is correct. In the second option also Q is 250 plus. So that is also correct. But C and D, they have given Q minus 250 Therefore, C and D are out of consideration. Either A or B is correct. In A as well as B, Q is given correct 250 joule. But what about W? Now find the W and delta U from their given data. What is given data? Q is given plus 250. Furthermore, volume they have given 1 liter to 10 liter. It is the process of expansion. Since this is the process of expansion, whether work done is negative or positive, it must be negative. Work done should be negative. See, it is not necessary to calculate the answers here. Since the process is expansion, work done must be negative. Now we have seen either A or B is correct. Because in A, Q is given positive. In B also Q is given positive. So either A or B is correct. Now see the work done W. As the process is expansion, we must know that answer must be negative. And W in A is given positive, B is given negative. So which is the correct option here? B. Second option is correct because W is given negative. So A is wrong itself. First we have eliminated C and D because Q is given negative. Now we are eliminating A because A is given positive. So correct option is B. See here, important hint. We have not calculated anything. We have not performed the problem. We have not seen the calculations. But just from the general sense, we are identifying the correct option because it is expansion means negative and absorb means positive. So that combination only, W negative, Q positive, this combination is present in the second option B. Therefore, B option is correct. Now see question number 35. A system has internal energy equal to U1. Then see initial internal energy U1. Then 600 joule of work is done on the system. Means is it compression or expansion? Compression. Means this work done is positive or negative? Positive. Means plus 600. Then when 450 joule of heat is lost. Heat is lost. So what about Q? Q, is it positive or negative? Heat is lost means Q is negative, means minus 450 joule. Then the final internal energy U2 we have to calculate. We have studied this formula that U2 is equal to U1 plus Q plus W. Because initial internal energy get increased whenever heat is absorbed and whenever work of compression is done on the system by the surrounding. Here work done is from surrounding to system, compression 600. But heat is lost, therefore Q is minus. So on solving this, final internal energy will be initial internal energy plus 150. Now see the options. Option A, U1 plus 1050 joule, B, U2 minus 150 joule, C, U1 plus 150 joule, and D, U1 minus 1050 joule. So option C is correct, U1 plus 150. Option C, U1 plus 150. Now see the question number 36. Now see question number 36. Question number 36. If 2500 calorie of heat is added to the system, this heat is added means Q will be plus 2500 calorie. Heat is added means absorbed. So Q is positive. While the system does work equivalent to 3500 calorie by expanding against surrounding, means it is the work of expansion. So W is nothing but minus 3500 calorie. And simply value of delta U we have to calculate. Delta U we have to calculate according to first law of thermodynamics. See here, 2500 calorie heat is added, means heat is absorbed, therefore Q is plus 2500. Then while the system does work equivalent to 3500 calorie by expanding against surrounding, so it is work of expansion, work done is negative. Calculate delta U. Very simple. Delta U will be equal to Q plus W. Q is 2500, W is minus 3500, so answer will be minus 1000 calorie. Very simple question. Now see the options. 4 options they have given. Option A, that is this one, minus 1000 calorie. B is plus 1000 calorie. C minus 6000 calorie. And D plus 6000 calorie. We are getting minus 1000 calorie. Therefore correct option is A. A is the correct option for that question number 36. Now question number 37. A gas present in cylinder fitted with frictionless piston expands against pressure expansion. So work done is negative. Against pressure of 1 atmosphere from 2 liter to 6 liter. Expansion process. Initial volume 2 liter, final volume 6 liter. It is the process of expansion. In doing that, it absorbs 800 joule of heat from the surrounding. Therefore, we have to calculate the increase in internal energy. So first of all, calculate the work done during that irreversible process. See here. In that process, they have given constant external pressure against pressure, that is equal to 1 atmosphere. P external will be 1 atmosphere. V1 2 liter, V2 6 liter. So calculate work done. dW is equal to minus P external into delta V, V2 minus V1. So minus 1 into V2 is 6 minus 2. So minus 1 into 4, or it is equal to minus 4 liter atmosphere. Minus 4 liter atmosphere. But see here, question number 37. It absorbs 800 joule of work, and we have to calculate the increase in internal energy. Heat is given in joule, and work we are getting in the liter atmosphere. So this liter atmosphere should be converted to joule. Therefore, we know 1 liter atmosphere will be equal to how many joules? 101.32 joule. We have minus 4 liter atmosphere will be equal to minus 4 multiplied by that factor. So it comes equal to 4 to the 8, 4 3 are 12, 4 1 are 4 plus 1 5, 0, and then 4. So we have minus 405.28 joule of work. Now Q is given. It absorbs 800 joule of heat. Means Q will be equal to plus 800 joule. Now we can calculate delta U is equal to Q plus W. Since Q is 800 and W is minus 405.28. So 800 minus 405, it is approximately 395. Plus 395. Now let us see the options. Question number 37. Options they have given First option 698.7 joule, second 1205.2 joule, third 394.8 joule, and last 597.4 joule. So they have given third option 394.8 joule, and that is what we are getting, that almost equal to 395. So option C is correct. For this question number 37, option C is right. Question number 38. The incorrect statement in relation to first law of thermodynamics, that is delta U is equal to Q plus W, is incorrect statement. Incorrect. See 4 statements. We will see it one by one. First statement is Q is positive if heat is absorbed and Q is negative if heat is released by the system. So is it correct or incorrect? That is correct, because this Q is positive if heat is absorbed and negative if heat is lost. That is sign convention we have studied. So A is correct. We have to identify the incorrect statement. Second, delta U is positive if internal energy of system increases and delta U is negative if internal energy of the system decreases. That is also correct. This delta U is positive if internal energy increases and negative means internal energy decreases. So B statement is also correct. We have to identify the incorrect. Now option third, C. Option C is if work is done on the system, W is positive, and if work is done by the system, W is negative. That is also correct. Plus W means work done on the system by surrounding, and minus W means work of expansion, work done by system to the surrounding. So option C is also correct. Now see the last option. Q plus W is not a state function. They have given that Q plus W is not a state function. See, Q plus W is equal to delta U, and delta U is a state function. But they have given it is not a state function, but actually that is a state function. Therefore, last fourth statement, option D is incorrect. But here D option they have given is incorrect statement, and for this that is the correct answer, because we also have to identify incorrect statement. So option D is correct for question number 38. Now let us see question number 39. Now let us see question number 39 in an isobaric process. Isobaric process. 7 processes we have studied: isothermal, isobaric, isochoric, adiabatic, cyclic, reversible, and irreversible. So what are isobaric processes? They are the processes which are carried out at constant pressure. Constant pressure. Initial pressure is equal to final pressure. No change in pressure take place. No change in pressure will take place. And 4 options they have given. First option is Qp is equal to 0. Second, Qp is equal to delta U. Then Qp is equal to delta U plus P delta V. See here, little bit part of enthalpy we have to study. The correct option is C over here. Qp is equal to delta U plus delta V, because this equation we have studied. Delta U will be equal to Q plus W. So here delta U will be equal to Q minus P delta V. From this equation, Q will be equal to delta U plus P delta V. Here pressure is constant. We are considering pressure as a constant factor. Therefore, Q is nothing but Qp. Therefore, option C is correct. Now, question number 40. The work done by system is 8 joule. Work done by the system on the surrounding. System to surrounding. So, it is work of expansion. During expansion, rate of collision decreases. Therefore, energy of system decreases. Energy is capacity to do work. Since energy decreases, work done decreases. Therefore, work of expansion is treated as a negative work. W will be equal to minus 8 joule. When 40 joule heat is supplied, means heat is absorbed. How much heat is absorbed? 40 joule heat is absorbed, and we have to calculate the increase in internal energy. Very simple. Delta U will be equal to Q plus W. Q is 40, W is minus 8. Therefore, answer will be 32 joule. Delta U is equal to 32 joule. See the options. A 25 joule, B 30 joule. A 25, B 30, C 32 and D 28. So we are getting 32, means option C is correct. Third option is correct. Now see question number 41. At 302 Kelvin, 1 mole of an ideal gas is compressed isothermally and reversibly. Compression means work done, positive or negative? Positive work. Isothermal and reversible means work done is minimum or maximum? Maximum work is obtained, and that is a positive work. Whenever compression takes place from a pressure of 2 atmosphere to 10 atmosphere, change in pressure is given. Increase in pressure takes place. Increase in pressure means decrease in volume. Pressure increases, volume decreases, Boyle's law. So increase in pressure takes place. That is the process of compression. Work done is positive. The value of delta U and Q respectively will be. This is important question. Without any solution, we can find out the option. See, the process is isothermal. What are isothermal processes? The processes which are carried out at constant temperature, delta T is equal to 0. The processes carried out at constant temperature for which delta T is equal to 0 are isothermal processes. For those processes, since temperature directly affects the magnitude of internal energy, therefore delta U is also equal to 0. What they have asked? Value of delta U. So delta U is 0. Without any calculation, we can find out that since the process is isothermal, delta U is 0. Now what is the value of Q? Q we have to find out. See, for that purpose, we must know the equation of first law of thermodynamics. Delta U will be equal to Q plus W. We are not calculating any answer, but still we will get the correct option. Delta U is 0. So 0 will be equal to Q plus W. From this equation, Q will be equal to, what is it? Minus W. But itself the process is compression. Process will be compression. So work done is positive. Since this is positive, Q will be negative, and the option where delta U is 0 and Q is negative is nothing but the second option. So here for question number 41, the correct option we have to find out. For equation number 41, work done comes to be equal to positive, since the process is compression, and we have to find out the value of Q. Work done is positive, then substituted over there, Q comes to be Q over here. Since work is positive, Q comes to be negative. The second option is correct, option B. second option is correct because Q will be negative. See here, this answer is positive. Suppose it is 100, so it comes to be minus 100. So Q is negative and delta U is 0. They have given the 4 options. Option A 0965 calorie, 966 calorie. So without any calculation we can find out the correct option. Here the correct option for question number this one is B. B is the correct option for that question number 41. So with that we will stop the questions based on internal energy and first law of thermodynamics.